Welcome once again. So, we start our 4th week's course. We have already done 3 weeks for this calculus course. Hope you are enjoying it. Of course, 20 minutes, in 20 minutes we are just trying to give you the main glimpse of the ideas. However, today we want to mention that we are going to make a paradigm shift today from functions of one real variable to functions of 2 real variables. Many variables is just an extension, so we do not have to bother about it. So, we talk about essentially functions of 2 real variables. So, you might be wondering that okay, this is something very special or very artificial thing, and the function of real variable, just one real variable was a natural thing. But I would like to convince you that the function of 2 variables is quite a natural thing, because for example, when you add 2 quantities which you have studied in your childhood, when you add 2 quantities x and some y, you are essentially performing a function of 2 variable operation, where x is some number and y is some number, you are adding it, and let us call that addition f of x y, and hence this is an example of a function of 2 variables. So, this is a real number coming from R, and this is another real number coming from the real line, that is all. So, this addition is something which you learnt at childhood. So, when you start your childhood, you essentially start with function of 2 variables and not with function of 1 variable. So, your childhood school mathematics essentially talks about that in that disguise, which you of course do not know. See, in function of 2 variables, my domain has suddenly shifted from the real line R, which was my earlier domain, is denoted by the number line, to now the Cartesian plane with the x coordinates and y coordinates. You have to understand, if I take an xy point in the Cartesian plane, then of course from 0 I can join the point with the origin 0 0. So, if you look at this line not only has a length, but it has a particular direction corresponding to this given xy, because if I change my xy to say at some other point, I can take x hat and y hat, then the line that joins this point x hat y hat 2 0 0 has a different direction. Such quantities which has both magnitude and directions are called vectors, and you must have studied some of them in physics. So, that is why function of 2 real variables are sometimes called vector functions, real functions of vector variables. This x and y together represent some vector v. Now, after giving a few examples of functions of 2 variables, we would now also trying to talk about what is the meaning of limit and continuity when you are talking of functions of 2 variables. When you are learning calculus, the paradigm shift is from the function of 1 variable to the function of 2 variable. Lot of stories which occur in the function of 1 variable does not occur in the function of 2 variables. Once you know about 2 variables, you can just keep on adding more variables to it, you get the same story, but you just have to write more thing, do more algebra. But otherwise, the real conceptual crux lies in the change from the real line to the complex plane. The biggest interesting point in the from the real line to the complex plane is the loss of well ordering, in the sense that if you give me 2 real numbers, I can always say whether this now given a number A or B, I can always say whether A is bigger than B or B is bigger than A, or they are equal. Such a thing cannot be said when you are in the plane. So, let us take some examples. The examples are, for example, I think there is some jumbling of a paper that has to be corrected at the end, but just follow the talk. For example, I try to generalize my idea of a parabola, and then what you get is called a paraboloid. At 0 0 it takes the value 0 0 and of course there is nothing, it's like a hole inside, it's like a some sort of a bowl. An important role is played by something called level curves. For example, I fix the value of z naught. So, basically I want those x square and y square which gives me the value z naught. So, what will be those x and y's? So, those x and y's would be those x and y's on the plane for which x square plus y square is equal to z naught, or this is a circle with radius. So, this will be a this has to be a circle with radius root of z naught. So, these curves, that is for example set of all x and y such that x square plus y square equal to some c, this is called the level curve of f at the level c. They are quite useful in many contexts. Now, you might ask me what is the domain and range of a function of two variables, like we had spoken about domain and range of function of one variable. The domain and range of function of two variables of course has to be done according to the structure of the function. Here for example, it does not matter, whatever x y I put in, I can actually compute x square plus y square, it does not matter what is x and what is y, and the values that I will get are only positive quantities. So, in this case we will write that domain of f for this particular function is whole of the plane R2. The plane R2, the standard Cartesian plane, is the collection of these coordinates x y's, where x is in the real number, a real line, and y is in the real line, and both are real numbers. So, this is nothing but my standard plane which you are so habituated with it. Its symbol is R2, that is essentially telling that this is the Cartesian product of R with itself. Okay, there might be some people who do not know what Cartesian product, forget. So, plane is a symbol for the plane. Okay. Once this is done, let us take another example. For example, we have known about a circle. So, how do you write, this is the equation of a circle. Of radius r. So, what about a sphere? How do you write the equation of a sphere of radius r? So, sphere of radius r so can I represent it by the function of two variables? See, you know what a sphere is at the end of the day, you are quite, this is a standard object that you have seen, for example, a cricket ball or a football. These are spherical objects. Even the earth is sometimes thought to be spherical, and in most studies you consider it to be spherical, but though it is really not. So, how do I write? You see, I can always write z square as r square minus x square minus y square. Now, if you take the root, that will be plus and minus. So, corresponding to two values of x y, one given value of x y, there are two values of z. So, technically it is really not a function, because give me an x y, I am corresponding to, and I draw up perpendicular through it, it will cut the sphere at 2 points. So, if you take any x y and try to draw perpendicular through it, it will cut 2 points. So, this is very simple thing to understand. So, this is really not a function, but we can make it into a function by if I just write z equal to, just take the positive root and write. So, basically I am in this function, actually the graph of this function. So, of course, you can ask me what is the graph of a function of two variables, which is too simple that I have not even mentioned it. That is the collection of all x y, collection of all x y z, because you will now be in 3 dimension. So, if you want to talk about graph of f, so it is a collection of all x y z such that f of x y is equal to z. So, here the graph of this function would essentially be the hemisphere, upper hemisphere, and if you take minus sign, it will be the lower hemisphere, right. It is northern hemisphere. So, we are in the northern hemisphere. Now, here if you look at this thing very carefully, does it mean that this function is defined, this function if I put any x and y, it will be defined? The answer is no. Here the question comes, and what is exactly the domain, because in this particular function you should always have r square minus x square minus y square must be greater than equal to 0, or x square plus y square must be less than equal to r square. So, for this function to be defined, that this function z to be a numerical real value, one must have always that the functions of the x square, this x and y must be on and inside a circle of radius r. So, if this is my circle of radius r, so I can only consider x and y from this region. Any x and y which I take outside this region will immediately make this a negative number, and we are really not talking about complex numbers here, because we want a real quantity, because we want to represent it in the graph. You want to put a point on the real line on the z axis. So, here as you observe, there are 3 axes which we always draw, x, y, and this is the z axis. So, there are 3 axes. So, this is it is not so easy to visualize things in 3 dimension, because in 3 dimensions you are essentially looking at things standing in your own dimension. We are in a 3 dimensional space where we have length, breadth and height, but it is always to view things in 2 dimensions. That is why functions of real variables are so easy to study, because you are viewing the functions in 2 dimensions, essentially because we are in 3 dimensions, but once it comes to 3 dimensions, things become slightly difficult. So, that is why I do not know, solid geometry courses are almost abolished from the school level, but it is a very, very good thing that if somebody has an understanding of solid geometry, he has a much more better understanding of functions of 2 variables. So, for example, here the domain is of course this circular zone, and for this particular function z equal to root over r square minus x square minus y square, and it gives me real numbers. So, its codomain is of course you can say whole of r2 or whole of r, but its range of course is not the whole of r. Its range is of course not the whole of positive numbers. Its range varies from 0 to r. Now, we are going to end today's talk by talking about what is the meaning of limit and how do you talk about a limit in R2. We will compute them tomorrow, limit, continuity, those issues will come tomorrow, but it is very essential that you understand what is the meaning of taking a limit. Now, if you look at a point A in the real line, there is a real line, and I am talking about x approaching A. So, what does this mean? It means here I have only 2 degrees of freedom, that is x can come either from this side or x can come either from the other side, means x can come either from the right side, which I can write as right, and or it can come from the left side, which I write as left. So, any of the 2 ways, there is no other way, but this is exactly the paradigm shift I am talking about. When you come to a function of 2 variables and you talk about finding a limit of x and y, when x and y are going to some xi and eta, and you ask the question what is the meaning of this, then this whole thing immediately takes you to a different kind of conceptual regime. And it might not be in the schema of your things initially, but it is a very important thing that you have to get used to, and you have to understand this thing clearly. So, this is your point xi eta, and I want to say that x y is approaching xi eta. What is the meaning of the term x y approaching xi eta? That is the crucial thing. So, x y can come to it like this on a straight line, like, or you can approach x y, approach xi eta along a curve, you can approach xi eta along this curve, you can approach xi eta in very complex ways. So, there are infinite ways, and this is uncountably infinite ways, just like the uncountable infinity of the real line. It is uncountable infinite ways that you can approach xi and eta. So, when I am talking about the existence of a limit here, I am saying that whenever I compute the limit, I should compute through all possible paths, and you know that theoretically, practically, and when you think about it theoretically, it is a difficult thing. How can I take a limit over all possible paths, because I cannot even enumerate all possible paths, there is no question of enumeration, it is uncountably infinite. So, what I am supposed to do? So, this definition is not very clear if you just write that limit of f x y is equal to L. Once you want to do that, then you will see the power of the epsilon delta concept. So, that is why now first I have to define what is the meaning of a neighborhood of a point. Just like we have defined the delta neighborhood of the point A, say for example, A minus delta and A plus delta. So, it is the open interval around A on the real line, and we call this open interval delta neighborhood, NBD is short for neighborhood. So, for a real line, delta neighborhood is equal to A minus delta to A plus delta. So, what do I mean by a neighborhood here? That is a very important concept. For us, for all our studies, neighborhood would mean the following, that if I take a point xi eta, a neighborhood of a given radius r is a circular disk of radius r around the point xi eta, but I am taking everything inside the circular disk, but not considering its boundary. To understand what is this, we have to know how to compute the distance between a coordinate x y and the origin, and this is of fundamental importance. So, how do I consider the distance? So, you can drop here a perpendicular. So, this would be x and this would be y. So, the distance between them by the Pythagorean theorem, this is say my distance r, then r square is x square plus y square. So, the distance is, so r can be written as root over x square plus y square. Now, what about the distance between two points in the plane? That is more important. Suppose this is x and y and this is xi and eta. So, the distance between x and y, so I am writing simply dist is a short form of distance. Distance between x and y comma xi and eta is equal to root over x minus xi. So, you are subtracting the x coordinates from 1 and then y minus eta whole square. Now, how do I now define a neighborhood again? So, what is my delta neighborhood in R2? So, if you take the point xi eta, essentially you have drawn a circle of radius r. So, what is a circle of radius r? So, we have everything here, but not anything on the boundary. So, a circle of radius r which center at eta xi, xi eta is given by this definition, this equation rather, which you know from your high school. But I do not want things on the boundary, I want things which are strictly lesser than that. So, basically I want to collect all x and y such that this holds. So, the delta neighborhood is usually given by this symbol B delta at xi eta, delta neighborhood. So, it collects all x and y on the plane which satisfies this formula, which satisfies x minus xi square plus y minus eta square is strictly less than r, which is same as x y element of R2 root over x minus xi whole square plus y minus eta whole square strictly less than r, which is same as x y in R2 such that the distance between the points x y and xi eta must be less than r. Sorry, this is not delta neighborhood, this is called r neighborhood, because my radius is this delta actually talks about the radius. So, I have taken here r, so it is the r neighborhood. So, let me just write the r neighborhood. So, see, so it consists of all the x y's which are not on the boundary of the circle this, but they are inside the boundary. So, it has it is all points for which they are not equal, but strictly less. So, I collect all those points and then that points are called the r neighborhood. Sorry, I just mentioned the delta neighborhood because I was talking about the real line just a few minutes ago. So, that is same as this, if you take the root. So, if you take the root, this will become r, not r square, and then this is same as telling from this definition that the distance between these 2 points is strictly less than r. So, consider all x y in R2 such the distance between x y and xi eta must be strictly less than r. So, that is called a neighborhood. Now, once we have this definition, we can then speak about limits and continuity, which we will start in the next class, and we will do it through the epsilon delta definition. Thank you very much.